Okay, then let's begin with the background story or the requirement. So we are going to build the attendance app for a teaching institute where we have the concept of students. A set of students, they enroll or they take admission in that institute. We can think it of that way. And then we have the concept of courses. So that institute offers a set of courses. Now see here, in this application or while building this application, we do not need to worry about like which department, which program. We are not concerned about that thing. As far as the attendance is concerned, those details we can omit. Okay. And then we have the concept of faculties. It's obviously in a teaching institute, we need to have the concept of faculties. And then also we have the concept of sessions. Sessions are something where the courses begins and the courses ends. It means, say for example, in India, in 1 year, there are 2 sessions. One is a spring session and this autumn semester or the autumn session. But exactly how many sessions will be there in a particular year, that really doesn't change anything about this application. But we have the concept of sessions. There could be 1 session in a year, or there could be multiple sessions in a year. Okay. Now let's see what happens or how these different concepts actually interact. Okay. In each session, one particular student, see here, each student will be identified by his or her roll number. Now the roll number here, for example, I am writing here it as like CSB21005. It is an alphanumeric it is a string, alphanumeric characters. But the thing is, for the development of the application, logic wise or coding wise, this restriction is not that important. It could be any, it could be simply a number that identifies a particular student, or that could be a string like this that identifies a student uniquely. Only requirement is that the roll number should be unique. That is, no two students will have the same roll number. That is quite obvious, right? Say for example, what I was telling you is that each student, say for example, I'm talking about this CSB21005, this particular student, each student will be taking a set of courses in a particular session. See here, in each session, say for example, it is 2023, say autumn semester. In this session, this particular student has taken these 3 courses. That is the meaning. So in each session, a student will take, or a student will register for a set of courses. Now see here, 2 students, say for example, this is CSB21005, another student, say for example, CSB21006. So whether that student will also take these 3 courses or a different set of courses, that thing is actually, we are not concerned about that thing. We only know that a student will register a set of courses in a given session or in a given semester. Okay. Now, the second rule of the game is each faculty will be taking a set of courses in a session. In a given session, a faculty or each faculty will be taking or will be teaching a set of courses. He might teach 1 course, he might teach, or he or she might teach more than 1 courses. Like this, say for example, this faculty, Dr. RCB, suppose he teaches CO101 and CS333. See here I'm writing these are the course, you can consider like these are some unique course code. So a course code will uniquely identify one particular course. So suppose and this you can consider as the faculty ID or faculty code, something like that. So each faculty will be teaching more than teaching 1 or more courses in a particular session. Now here I have written 2 faculties, Dr. RCB and Dr. Paul, say. It might happen that actually the same course, you can see here CO101 and CO101, the same course can be taught by 2 different faculties in the same given session. This might happen. Okay. So this is the more or less, these are the rules of the game. Now, more concretely, if you want to see, like in a given session, if we know which faculty we are talking about, and if we know which course we are talking about, then immediately in that course, whoever the students are there enrolled will get the list automatically. we should get the list. That is, if we specify the session, if we specify the faculty, and if we specify the course code, then immediately in that course, whatever the students enroll, because we know like in a given session, a student registers for a particular course. So in that particular course, say, whoever the other students are there who have enrolled in that particular course, so these are the students actually. So if we specify the session, the faculty, and the course code, we should get a list of all the students who enroll for that particular course in that session. And once we have that list, give on a given date, then we can give the attendance, like, you know, a tick mark means present, this is absent, this is present, like that. This is an overall picture, like this is what we want to build. I just, you know, wanted to tell you the background story. So background story is something like this. Again, I'm just recapping it in 1 minute. Like we have students, courses, faculties, and sessions. In each session, a student will register for one or more courses. And again, a faculty will teach one or more courses. And again, it might happen that actually one particular course can be taught by two different faculties in the same given session. Now, let's try to visualize these requirement in the form of some sketches. So first thing, or you can think it of like, you know, in the form of some features. The first thing that we want to develop is a login page. Now, one thing you realize here that this system, whatever the attendance management system we're going to build here, only user is the faculty. It means faculty will be the only user who will interact with the system. Although we are maintaining the information of students, but student will not directly interact with the system. Only faculty will log into the system. He or she will give attendance to the students. And if needed, he or she will be able to, you know, generate some report. That's all for this application. Obviously, one can upgrade these, or one can add modules which will allow a student also to interact with the system. But for the time being, for this application, we are concerned only about the faculties. So what we'll do is we'll first design, or we'll first, you know, in our application, there will be one login page for the faculty where the faculty will enter their code or some unique identifier that will be considered as the username of the faculty and the corresponding password. And there will be one call for action button, like say go or something. If the user clicks on this button and if the username and the password they are valid, then the faculty will be redirected to this attendance page. Now here, when the faculty is coming to this attendance page, you should realize that he or she will be actually going through the login page. So automatically the faculty ID will be known to the system. Okay, which faculty has logged in or which faculty is viewing this attendance page, that will be known to the system. And then the next question is, you see here, these are three things that we have to specify. We know, like, you know, when the faculty reads that attendance page, we know which faculty is viewing the page. The next question is what session and what course. So in that case, what we'll be doing is, for this session, we'll be creating a drop-down menu. This symbol usually represents, it's a drop-down menu. So if the user clicks here, he or she will be able to see all the available sessions. That is one option. But another option we can do is that, you know, automatically we can make use of something called as your current session. Right? So if we maintain the current session, then we by default here, whatever the current session it is, that will appear here by default. But if the faculty wants to change it for some reason, he or she can click on this drop down and he or she can select different sessions. But one option we should need here, that is the faculty should be able to select a session. Done, right? Now, once the faculty, see here, we know the faculty, we know the session. Once we select the session, then immediately from the faculty and the session, we will be able to, you know, or in the user interface, we should display what are the courses this faculty teaches in that particular session. If the faculty change this session, then this list of courses will be different. Okay, so the thing is that after login, the attendance page will come. By default, we know which faculty has, which faculty is viewing the page. Then the faculty has to select the session. Once the faculty selects the session, he or she will be able to see the courses taught by him or her in that particular session. Then the faculty will click on any one of these courses, and once it is done, it will show, our application will show the list of all the students here like this. Say for example, what is the roll number, what is the name of the students, and along with a checkbox. So this checkbox will be used to indicate whether the student is present or absent. Now see here, another important information you have to specify, that is this date component. See, in that session for this course, these are the students, and then by default, the current date will appear here. But if the faculty wants to see the attendance of some previous date, he or she will be able to click here and change the date. And in that case, these checkboxes, some of them will come as tick, some of them will come as not tick. So if it is a tick like this, it means that these two students were present on that particular day, and this student was absent on that particular day. So this is more or less, these are the functionalities that we want in our application. So this is the main functionality. But over the days, like the faculty is taking attendance each and every day like that. Now what happens, at some point of time, the faculty might need to generate some report. So one very crucial report is the attendance report. So what the faculty will be able to do is, see here, anyhow the session is selected, the course is selected, session and course is selected, we know the faculty, then we can actually generate the report of that particular course, attendance report. Like in that course, we can, this is the minimum report sort of you can generate. In that course, what are the students, like roll number of the student, name of the student, total number of classes taken by that faculty, and what is the percentage of attendance of each and every student. Here obviously this total number of classes is a constant thing for a particular session and for a particular faculty for a particular course. So we can, instead of representing it as a different column, we can write here, okay, total number of classes, or say for example 100 classes, then we do not need this. But anyhow, that is something that we can decide towards the end when we will be actually writing code to generate this report. But overall, we need a report that looks something like this. So these are the features that we want to build in our application. Now we know what are the features that we want in our application, or what features we want to build. Now, to build those features, the first thing that, or the first question that we have to answer is how we are going to store the data related to that application. So for that reason, what we have to do is, first thing that we have to do is we have to design the database. And to represent the design of a database, we can make use of one tool which is known as the ER diagram. It represents actually, like, this is the easy way of telling people what is the structure of a database, or what are the tables that we have in our database, what are the columns that we want in our database, and what are the relationship among the tables which are there in the database. So this tool we'll be using, this is known as the ER diagram. For our small application, the ER diagram will look something like this. Now you notice here these rectangles, these are known as the entities there. So we have 4 rectangles here, the 4 basic entities, as I said at the beginning. No, so these are the concepts which will play an these are the characters in our drama sort of. Okay, so this is the student, course, faculty, and session. So we have to maintain the information related to all these different entities. Like we have to maintain the information of all the students, we have to maintain the information of all the courses, all the sessions, and all the faculties. And here you can see this ID, roll number, name, these are known as these are called as the attributes of that particular entity. It means regarding a student, or with respect to a particular student, what information we want to keep track of. We want to know what is the ID of the student, say, what is the roll number of the student, what is the name of the student. If we want to know something more, like for these applications, we do not need to say, for example, we do not need to keep track of what is the DOB or what is the gender of the student. Those informations are not related or not important with respect to this application. But if you want to make this project bigger, and if and for some module, you might have to actually keep track of those other details also. So you can easily add them as different attributes. But for this application, these 3 attributes will be fine. Similarly, for courses also, we want to keep track of some information, like what is the ID of the course, code of the course, title, and what is the credit information of that course. Similarly, for session also, what is the ID, what is the year, what is the term. Like year could be, say, for example, 2023, term could be, say, for example, spring, like that. And what is the starting date and ending date? These two attributes are not needed for our application, at least at this stage. But I'm just showing them, like you can add them very easily and you can extend the functionalities of your application. And then for faculty also, we have ID, code, or username. We can use them interchangeably. We can call it like the code of the faculty or the username of the faculty. We need to have a password for this faculty because this faculty is going to enter into the system by specifying this password. We are not keeping track of any, we are not maintaining any password for student because student is not going to enter into the system, at least in this application. Okay, so this is the password and the full name of the faculty. For some reason we might want that, so we will keep track of the full name of the faculty. Now, these are the, you see here, these rectangles, these are the basic entities, or these are the entities of the, in the ER diagram. Along with these boxes or rectangles, you can see these these diamond shaped boxes here. These are known as the relationship. Now, see what I mean by this is that, see here, I'm using three different color. One is this blue, one is black, I guess, and this is this orange color. So we have three different relationships. Apart from these basic entities, we have three different relationships here. So the first relationship is among student, course, and session. You see here, you can consider like this is a relationship where a student is also participating, a course is also participating, and a session is also participating. So you can think it of like this. And this relationship, I'm calling it as, register. You can give any name you want, but here I think register is a meaningful name here. You can see it in this way. In a particular session, a student registers for a particular course, like that. So here I'm again writing this cardinality as M. It means one student can register for multiple courses. One course can be registered by multiple students in multiple sessions, or in a session there could be multiple students registering for multiple courses. So usually when it is a ternary or m-array relationship, all these are M. Okay. Now the main point is that these three entities are participating in this M-array relationship, which I'm calling as registers. Similarly, a faculty, a session, and a course, they also participates in a relationship. You see here, in a particular session, a faculty teaches a set of courses. See, one faculty, these are also M relationship. One faculty can teach more than one courses in a particular session, or one faculty can teach one course in more than one session, like that. So all of them are M relationship. But here you see here in this black relationship, this faculty, session, and course, they are participating. In this blue relationship, student, course, and session are participating. And this orange relationship here, all these four basic entities are participating. See here, and this relationship I'm mentioning as attendance relationship. See here, if in a particular session a faculty gives attendance to a particular student for a particular course, all these informations are needed, and this relationship captures that that fact. And along with this, actually here I have to write another one attribute. See, these relationships, the way a basic entity or the way an entity can have an attribute, same way a relationship also can have an attribute. Here actually I have to add an attribute which is, say for example, on date, on which particular date the attendance is taken. So this attribute I have to add here. Okay, but more or less this is the ER diagram for our simple application. Now, the next question is, how do we convert this ER diagram to a database schema, or in more simpler term, like to a set of tables? Like from this ER diagram actually tells us what are the tables that we have to create in our database. So for that reason, if we want to convert this ER diagram to a set of tables, they will look something like this. See here, for all these basic entities, like all these entities actually, student, course, session, and faculty, we have to create a table. In a ER diagram, whatever the entities are there, for all of them, we have to create a table, and whatever the attributes of those entities are there, they will come as the column of the table. You see here, for student, I'm creating a table. See, here I'm writing as student and here I'm writing as student details. This is just representation. So you should understand that, okay, this student details is actually the corresponding table for the student entity. Okay, so student details, I'm calling it. You can call it very easily student also, no problem. That really doesn't matter much. So here ID, roll number and name. Here see ID, roll number and name. These attributes I'm putting as the columns of the table, and this ID column of the table will be the primary key. Primary key, technically, what does it mean is that, like, in that table there will be, like, there could be, say, hundreds of rows could be there. So this ID value will not be duplicated in any row. That is the primary key of the table. Okay, and see, you might be thinking, okay, that's good, but the roll number also should not be duplicated in over any rows. So yes, that is, one can use roll number also as the primary key, but here I have decided, okay, each student will be given a unique number automatically generated, and that will be used as the primary key. To apply the constraint, like roll number also should not be duplicated, I'll be using, or we can use another database constraint, which is known as the unique key constraint. That constraint, if you apply on a particular column, it will tell that, okay, that column, although it is not a primary key, but the values of that column over the rows, they cannot be duplicated. We can, we can handle it that way. Okay, but the point here is that, again, for these student details, for this student entity, we will be creating a separate table. For the course entity, we will be creating a separate table. For the faculty entity, we will be creating a table. For the session entity, we will be creating a table. So these four tables are directly one-to-one mapping of these four basic entities, or sorry, these entities in this ER diagram. Then what about the relationship? Now see here, in a ER diagram, if the relationships are like M array relationship, like M is to M, or like there are more than, here actually, coincidentally, all these relationships are like more, sorry, the number of participant entities for all these relationship, they are more than 2. So these are known as M array relationship, like more than 2 participants. So if it is the case, then for each of the relationship, we have to create a different table. But easily in ER diagram, you will see relationship something like this, where there are only 2 participants, and one is there are only 2 participants. One side is 1 and other side is M. In that case, you might not have to create a separate table. There are some rules, but here coincidentally all of them have more than 2 participants, and for all of them we have to create a separate table. So we have 3 different relationships are there. For all of them, we'll be creating a separate table. So course registration, course allotment, and attendance. So this register relationship I'm writing here as course registration, and this teach relationship I'm writing here course allotment, and this attendance relationship I'm writing here attendance. I'm mentioning here it as attendance. That is fine. But how do we decide what are the columns should be there in that table? See, for the entities, it is not a problem, because we know, like, this is an entity. So what are the columns? These are the columns, the attributes, whatever the attributes of that entity, those will be the columns of that particular table. But what about a relationship? Here we do not have any attributes. I didn't write any attribute here. No attribute here. Here, although I said that there will be one attribute on that, but you see, other than that, on that attribute, there are no attributes there. Then how do you decide what are the columns, or which will be there in the corresponding table? So the rule is that if it is a relationship like this, and we are creating a separate table for that relationship, the primary key of all the participating tables, like this, in this relationship, this is one participating table, this is another one, this is another one. So the primary key of this table, and this table, they will become the columns of this relationship table there. Okay, and automatically they will become the primary key of the table. You see here, for example, this register relationship here, I'm writing course registration, student ID, course ID, and the session ID. They are the primary keys of the corresponding entities participating in that relationship. Similarly, course allotment, or here I'm writing it as teach. So faculty ID will come, session ID will come, and the course ID will come. So that's what. Course allotment, faculty ID, course ID, and the session ID. And see, all of them will combinedly, they will become the primary key of this particular table. Similarly, for this attendance relationship, we will have student ID, faculty ID, session ID, and the course ID as the primary key of this attendance table. Like student ID, session ID, student ID, faculty ID, and the course ID. Along with that, I have added here two more attributes. One is the date attribute and the status attribute. Like on which date we are taking the attendance for that particular student, and what is the status, whether he or she is present or whether he or she is absent. Now see this status, you can omit this because on a particular date, if there is an entry, we can consider, okay, if there is an entry, then it means it is present. If there is no entry corresponding to a particular student, it means he or she is absent. We can handle the situation that way also, or explicitly we can keep a like status column there that will say either present or absent, and just by looking at the status, we know whether the student was present or absent. If the corresponding entry is not there at all, it means by default the student is absent. But if the entry is there, then we'll check the status. If it is present, it means present. If it is absent, it means absent. So some minor changes you can do in this arrangement, but more or less with this arrangement, we'll be following to the next step. And what is the next step? So we have decided like these will be, see, ultimately what we have decided is, okay, for our application, we want to create a database that will have these, how many, sorry, that will have these 1, 2, 3, 4, 5, 6, 7, that will have these 7 tables. So the next step will be to actually create these tables in the database. Now, before that, again, we need to know now, okay, till now, whatever it is that it was that I was talking about, they were all theoretical things like, okay, we'll be building an application, that application will have these features, and then this is how we design the database, and these are the tables that we want to create in our database. To actually do the thing where we're going to create these tables, what database, where, in our computer, how do we make our computer ready for that? So for that, actually, I will not get, take you into the details of like how to install the softwares and all. I'll be mentioning only, okay, these are the softwares that you need to proceed further. You can easily do a Google search and you can install those softwares in your computer, and it will be ready within 15 minutes. And you can do it very easily of your own. Okay. So, but before that, but then also let me tell you like what is the basic arrangement, like how things will work. So to actually develop this application, what are the things that we need is, we need one web server. We need this particular computer. We want to make our computer we want our computer to have a web server and a database server. See here, this is web server and the database server. These are two software components. You can think it of like these are two special software. This web server component allows your computer to receive HTTP request, on port number 80 or any specified port. Okay, so that is the task of this web server, and when it receives those requests, then it can process those requests, and based on the request, it can actually execute some programs, and those programs could be written in any server-side programming language. Like here we'll be using the PHP programming language for the server-side coding. So, but the moral of the story here is that we need that software to be installed in our computer, the web server software. Along with that, we also need this database server software to be installed in our computer. Now, what this database server software allows us to do, it allows us to maintain databases in our computer. Now, what are databases? Databases are nothing but a collection of, you can think it of like in the simplest term, database is nothing but, more specifically, relational databases. Relational databases are nothing but they're a collection of some tables. Like see here, for example, in our database, it will be a collection of 7 different tables there. So this database software allows you to create a database. Say, for example, database 1, database 2, or whatever the name you want to give your database, you can give it. So first thing is that you have to create a database, and inside that database, we will be actually creating those 7 different tables. Okay, so this is the requirement. Now, to make our computer ready for this, to fulfill this requirement, what we can do is you can do a Google search about the XAMPP server. You can install, you can download, and you can install the XAMPP server in your computer. As soon as you install XAMPP server in your computer, automatically it will install the web server and the database server. it will not take more than 10-15 minutes for you to install this jam server. It's a clear, very straightforward